Bunkering is a very important procedure on board ship, carried out regularly by ship's crew. Unfortunately, it can also be a slow, long and tedious process. All too often, attention to detail can slip with possible disastrous consequences. If mistakes are made during bunkering, the results can be very costly, time-consuming and potentially dangerous. Poor communication and a failure to follow correct procedures increase the risk of pollution or personal injury. Disputes, fines and litigation can be avoided by adhering to regulations, by taking proper, uncontaminated and representative samples, by keeping proper records, and by checking the quality and quantity of bunkers delivered. Bunkering may be a routine operation, but it has to be an exacting process. This is why it's most important to follow good bunkering practice. You can take bunkers from shore tanks or have them delivered to your ship by barges or road tankers. The basic principles of quality and quantity control are the same in each case, although applied differently to suit the situation. In this program, we will illustrate barge delivery, as this is available in all parts of the world. We will take you through this process, showing how to complete a safe and successful bunkering. This involves ordering the correct bunkers for your engine, taking account of new MARPOL Annex 6 and EU regulations, preparing for receiving bunkers, involving risk assessment, provision of anti-spill measures, firefighting equipment and personal protective equipment, and by checking tank capacities prior to delivery. Verifying the quantity and quality of bunkers offered against the order. Checking tank levels on the barge before and after delivery. Verifying the method of obtaining samples and ensuring that the bunkers are loaded into the designated tanks on board.
Oh, hi Chief. Oh, no. So, here are the distances for the next voyage.
Safe bunkering begins at the point where an order is made up for your next bunkers. In some instances, the ship's shoreside management team carries out the ordering of bunkers and notifies the ship where and when delivery will take place. But in most cases, it is the responsibility of the chief engineer. In either case, the bunkers needed for the voyage ahead are checked in line with recommended ISO and CMAC standards, and the engine manufacturer's requirements. If appropriate, the requirements of the charter party are also adhered to. In addition, MARPOL Annex 6, which regulates air pollution from ships, now requires him to make sure that the bunkers he orders currently must not contain more than 4.5% sulfur. If sailing in a sulfur oxide emission control area, or SECA, his bunkers used must not contain more than 1.5% sulfur. Furthermore, in EU waters, sulfur limits have also been set for marine gas oils. If the voyage ahead requires the ship to sail into a SECA, the bunkers required, containing less than 1.5% sulfur, must be loaded into separate tanks from the conventional higher sulfur content bunkers, and the fuels changed over prior to entering the SECA. The changeover time and ship's position must be logged. The chief engineer must ensure there are separate tank capacity and treatment plants available to facilitate the changeover. The chief engineer wants to have the best bunkers available within the specification limits so that he will get optimum performance out of the engines while minimizing maintenance time or downtime for repairs. Simply buying at the cheapest price could turn out to be the more costly. The chief engineer checks his order with the master.
I've calculated the bunker figures and this is the amount we need.
Okay. 900.
Together they verify the next bunkering port, the grade and quantity of bunkers they require there, the grade and quantities they already have on board, and the spare tank capacity on board ship, always allowing for a sufficient margin of safety.
Thank you, Chief.
If all checks out, they transmit the request to head office for ordering. Close communication is vital between head office, the charterers if applicable, and the ship to ensure that the right quantity and quality of bunkers are ordered. It is essential to schedule bunkering at ports where bunkers meeting the required specifications are available. This is the first step in reducing the chance of fuel problems on board. It should also be pointed out that regulations regarding bunkering operations vary in different ports around the world, particularly in the United States. Any local restrictions or procedures should be consulted prior to ordering. Ship's personnel must carry out a number of tasks in preparation for receiving the bunkers safely. The bunkering station must be cleared, making sure drip trays are cleaned and in place, and any sampling equipment made ready. It is often now a requirement that representative samples are taken at the ship's manifold during bunkers transfer, in addition to samples being taken on the barge. The shipboard drip feed sampling equipment should be checked for correct function, and all necessary new sample bottles, labels, lids and seals are made readily available. Firefighting equipment and anti-spill material must also be placed near the manifold in case of an emergency. At the same time, all scuppers and other deck openings must be sealed or closed. Any possible spillage must be prevented from leaving the ship. The ship's Shipboard Oil Pollution Emergency Plan, or SOPEP manual, should also be made available, and, if possible, the material safety data sheet of the fuel supplied should be consulted. Smoking must be prohibited in the vicinity, and in the case of fire, assistance must be sought from shore authorities. During daylight hours, the Code B flag should be flown throughout the bunkering operation, warning passing traffic that a fuel transfer is taking place. If bunkering takes place at night, a red light must be displayed at the masthead. Additional deck lighting may need to be set up at the bunker station. A risk assessment meeting must be held on board before the barge arrives at the ship, covering personal safety, pollution and fire prevention, and dealing with the possibility of accidents. All the preparation tasks are double-checked to make sure that they have been carried out and that everyone understands their role in the operation. Finally, all deck radios are checked for function and that they are fully charged. In addition to standard personal protective equipment, such as hard hats with straps and gloves, all personnel involved in the bunkering operation must wear eye protection when working near the manifold. Spare safety glasses, gloves and harnesses should be placed near the bunkering station, ready for use if required. In the engine room, tanks that will receive the new bunkers must be made ready, and the valve train must be lined up to the bunker station. The ship is now ready for taking bunkers. It is the shared responsibility of the masters of the barge and ship to ensure that the barge can be safely moored and the hose can be attached safely, taking the freeboard changes into account during bunkering. Circumstances may vary, but in most cases the barge master or bunker supplier's representative will want to come on board to discuss the order with the chief engineer. Likewise, an officer from the engineering department will be standing by to visit the barge to check the method of sample taking and to verify tank levels before and after delivery. Therefore, a safe means of access must be provided in accordance with local regulations. If the new bunkers are required to be loaded into a partially filled tank, a shipboard compatibility test can be carried out in accordance with manufacturer's instructions. Various test methods are used on board. Invariably, a spot test is used in this situation. If the two bunkers are not compatible, they must be segregated. The chief engineer and the barge master, or supplier's representative, check the bunker's requisition form against the delivery note to ensure that the bunkers delivered are those ordered. In particular, they must check the grade, the quantity, and any other specification stipulated in the order. The bunker's delivery note must now clearly show the sulfur content of the fuel in accordance with MARPOL Annex 6 requirements.
Okay, well for you, we have 900 tonne today.
Special attention must be paid to the quantities ordered if the order refers to two different bunkers with different sulfur content. For example, the order may refer to 750 tonnes of fuel with less than 4.5% sulfur content and 50 tonnes of fuel with less than 1.5% sulfur content. If the bunker's delivery note does not agree with the order, immediate remedy must be found. If two different grades of oil are to be delivered, it is recommended that the lighter grade be delivered first. This is to avoid contaminating the lower viscosity fuel by any heavier grade fuel that remained in the pipeline.
We need from you your agreed pumping rate.
Having resolved any unexpected issues, the chief engineer and the barge master agree on rates of delivery, usually starting slowly to allow checking that all the relevant valves are open and that the fuel is arriving at the designated tank. They also discuss maximum delivery pressure. Emergency shutdown procedure is agreed on, and their communication channels with each other are checked. Some ports, such as Singapore, require that a set of hand signals be agreed between the barge and the ship as a backup communication system in case of emergency. So what have we done so far? We have prepared all the material to deal with emergencies. We have prepared the ship for taking bunkers. And we have checked that the correct grade and quantity of fuel has been ordered, and that the fuel on the barge is the ordered grade. The rate of delivery has been agreed, and the channels of communication established and tested. But has the barge got the correct quantity on board? To check this, either the chief engineer or his nominee descends onto the barge and witnesses the opening barge tank gaugings before delivery starts.
0.954.
Starboard 0.954.
This measurement will be compared with the tank gaugings after delivery has been completed to arrive at the actual quantity delivered. Before delivery can start, a lookout is posted at the bunkering station and instructed to make continuous checks overboard to verify that no oil spill has occurred. Meanwhile, the chief engineer checks that the bunker's manifold is blanked off at the other side of the ship. An important procedure for any bunkering operation is the process of obtaining uncontaminated representative samples. The officer visiting the barge must check the methods and arrangements for the taking of samples and witness the fitting of the cubitainer. One of the most exacting procedures of sample taking is stipulated in Singapore, published in CP60 sampling procedures. In many cases, samples are taken at the ship's manifold in addition to the samples taken aboard the barge. Typically, a continuous drip feed sampler is used, secured between the flanges of the hose and manifold. In this instance, the barge master or a representative from the bunker's suppliers will want to witness the setting up of any shipboard sampling equipment. When taking bunkers from shore tanks, where the delivery line may be several hundred meters long, ship's personnel must ensure that the line contains the grade of bunkers ordered before any sample can be taken. Everything is almost ready. The chief engineer checks that the valve train from the manifold to the designated tanks is open and ready to receive bunkers. Once this is confirmed, he informs the barge that he is ready to receive delivery.
Okay, we are ready to start now.
Okay then, Chief. JDW, Santa Catarina, ready to start bunkers. Just about to open my valve.
The barge master acknowledges this and opens the valves aboard the barge.
Santa Catarina, JDW, we're all ready to start pumping. Are you ready, please?
Yeah, all ready.
Just about to start pumping now. Thank you.
Delivery starts slowly, and everyone involved checks for leaks, correct valve positions, and the arrival of the fuel at the designated tank. If everything is in order, then delivery can be established at the agreed pumping rate and pressure. The pressure gauge at the manifold must be monitored. If the gauge shows a rapid rise, pumping must be stopped immediately and the valve train to the designated tank checked. An overflow valve usually opens automatically on some ships to reduce pressure and prevent spills. Bunkering can take several hours. It is most important that during the entire process, lookouts are monitoring transfer both on the barge and at the bunkering station. In the engine room, the duty engineer must monitor the tank levels involved and slow down delivery in good time for topping off. Tanks must be filled in the correct order to maintain stability. To ensure that this is done, good communication links must be in place between the engine room and the bunkering station, as well as between the ship and the barge. Any mistake in calculating tank capacities can result in spillage and delays. If such a thing happens, pumping must be stopped immediately. Valves along the delivery line must not be closed, however. It is the duty of the barge to ensure that delivery is stopped as soon as possible. Any spillages must be regarded as an emergency situation. Spilt oil should be treated and cleared away as soon as possible, ensuring that no fuel leaves the ship. If there has been any contamination, the harbour authorities must be informed and help requested to minimise the environmental damage. All such events must be logged and immediately reported to the proper authorities. For that reason, the posting of a lookout at the manifold is vital. Failure to do so is a dereliction of duty. Towards the end of delivery, contact with the barge should be re-established and the barge warned to stand by to slow down the delivery at least 15 minutes before stoppage.
Reduce the pressure.
Remember, a tank must not be filled to more than the safety level stipulated by the company. There is a gradual slowdown of delivery before the pumps are stopped.
That's Katerina, Janie, pump all stop, valve closed, thank you.
At the end of delivery, 4 identical samples are taken to obtain uncontaminated representative samples of the fuel delivered. In most cases, 3 commercial samples and 1 MARPOL sample are taken. Ship's personnel must witness the creation and sealing of the 4 sample bottles and their labelling. Likewise, if the sampling has taken place on board ship, the bunker's master or supplier's representative will also want to witness the sample creation, sealing and labelling. The labels are logged and countersigned by both parties. It is vital in the event of a dispute that the samples are the correct ones and that they have not been contaminated or tampered with.
2 starboard, 6 meters.
Ship's personnel must also check the barge tank levels or the meter reading to verify the actual quantity delivered.
Okay.
If these figures are agreed, the bunker's delivery note can now be completed, countersigned, and the ship's seal attached. Should there be a disagreement, a letter of protest must be presented to the barge master to register this.
Government service tax.
The various samples are exchanged. If both the ship and the barge have produced samples, the barge master or supplier's representative will take at least one of the shipboard produced samples for the bunker supplier's records. To avoid confusion, MARPOL samples have a prescribed special label. The seal number must be recorded in a dedicated logbook. The sample logs, as well as the bunker's delivery note, must be kept for 3 years. The MARPOL sample must be held until the fuel is used up, or for at least 12 months. As bunkering is an oil transfer, it must be noted in the oil record book where appropriate. A port state control officer may wish to inspect any of these documents and the MARPOL sample at any time. Some companies are taking the extra care not to use the fuel until test results are returned to them from an officially recognised testing agency. This was a good bunkering procedure, in which we stressed the importance of preventing spills if possible, or responding quickly if something goes wrong. So what were the key elements of a successful bunkering? Ordering the correct grade and quantities of bunkers. Preparing the ship for receiving bunkers. Carrying out a risk assessment. And providing all the necessary measures to prevent an oil spill, deal with emergencies and personal protection. Verifying that the specified bunkers are on board the barge. Verifying quantities by taking ullages before and after delivery. Agreeing the communication methods between barge and ship. Agreeing the pressure and rate of delivery. Slowing down delivery in good time. Obtaining good representative samples of the delivered fuel. Finally, ensuring that personnel assigned duties during bunkering know what is expected of them. The chief engineer and his crew have ensured that they have followed all the recommended procedures, and they can now feel satisfied that this was a job well done.